equilibrium positions of 9 equally spaced particles in a medium. The lower diagram shows the positions of the same 9 particles when a longitudinal wave is travelling through the medium. The wave is shown at time t equals 0 travelling to the right. Just to clarify, that is the lower diagram. The frequency of the wave is 0.5 Hz. That means time period equals 2 seconds. Which graph represents the displacement of the particles at a later time t is 0.5 seconds? So relating that, we know that is a quarter of a cycle later. So in order to get the displacement of the particles after, it might be a good idea to draw what they look like now. So plotting this, starting from 0 all the way to 8, we would have the particle at 0, we can see here is at 3.5, so I'll just put that here. The particle at 1 is at 2.5. The particle at 2 is still at equilibrium. Particle at 3 has actually moved 2.5 to the left, so that counts as a negative displacement. The particle at 4 has actually moved 3.5 to the left, so that's the maximum displacement here. Particle at 5 is at 2.5 to the left. Particle at 6 is at equilibrium. Particle at 7, well, where is that? That is 2.5 to the right. The particle at 8 is 3.5 to the right. So if we connect these like so, we should get something that looks like a cosine wave. And if you notice, the wavelength of this wave is 8 centimeters. So if we move this wave by a quarter of a cycle, so if it's traveled to the right by a quarter of a cycle, we should get something that looks like this. So this phase here would now be here. There, the phase for the particle that was at 1 would have now moved here. And then each of these would look something like that. Like that. How do we connect the last part? Well, clearly, if we translate a cosine wave to the right, we do just get a sine wave. So if we translate by a quarter cycle. If you remember, the wavelength of the wave was about 8 centimeters, so we need to look at something that matches this. This must be answer A. So again, just to clarify, I drew the positions of the particles at time t0, and then the wave has moved by a distance, well, a quarter of a cycle, so a quarter of a wavelength. So each part of the wave would have moved here, 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 and here. Again, these are particles just moving longitudinally, so their displacements, the particles themselves are just oscillating back and forth about their equilibrium. But in terms of the parts of the wave, so the particle that would have maximum displacement, before that was particle 0, and then now that is particle 2, which has maximum displacement. So after a quarter of its cycle, it has maximum displacement. Whereas the particle 0 has 0 displacement, if you look at the purple section here. So yeah, this is the answer. The answer is A.